The Doppler effect, discovered by Christian Doppler, an Austrian physicist in 1842 in Prague. The Doppler effect is formally described as the apparent variation in any emitted wave, such as sound, as the source approaches or moves away from an observer. But first we must ask ourselves, what's a wave? What's wavelength? What's frequency? Imagine we have a cicada named Freddy. Freddy is emitting 2 chirps per second, or 2 hertz. These are the waves. Waves can be defined as an oscillation or moving up and down at a constant speed accompanied by a transfer of energy traveling through space or mass. The distance between each wave is called the wavelength. Freddy emitting the 2 hertz per second will reach me at a constant rate. This is called frequency. Frequency can be defined as a number of crests of a wave that move past a given point in a given unit of time. Like we saw in the classroom, if both the source of the sound and the observer are stationary, then those sounds will reach the observer at a constant rate. That is very similar to this rock dropping in water. Since the rock drops in at a stationary point, the waves will reach me at a constant rate, just like the Doppler effect. If Freddy, the source of the waves, moves towards you, then the length of the waves will become shorter. This means that the frequency becomes higher, meaning you perceive the sound as becoming louder. If Freddy is moving away from an observer, this means the length of the waves will become longer, making the frequency lower, and the observer will perceive the sound as becoming quieter. As we saw back in the classroom, as the source of the sound moves closer to the observer, the frequency will get higher. This means the wavelengths are getting shorter. The observer will perceive the sound as getting louder. This can be seen in the example of a truck. The wavelengths will get shorter as the truck moves towards the observer, me. As the truck moves away from the observer, me, the wavelengths will become longer, representing a decrease in frequency. The observer will perceive the sound as getting quieter. If the source of the waves, Freddy, is stationary, and the observer is moving towards Freddy, the length of the waves will become shorter, meaning a higher frequency, and the observer will perceive the sound as growing. If the observer is moving away from our stationary point, the wavelengths will become longer, meaning a lower frequency, and the observer will perceive the sound as becoming quieter. As we saw in the classroom, if the source of the sound waves are stationary and the observer is moving towards that source, the frequency will become higher. This means the wavelengths are becoming shorter. We can see this in the example of the observer moving towards a source throwing wiffle balls. As the observer moves closer, the wiffle balls will have to travel a less distance to hit the observer. As the observer moves farther away, the wiffle balls will have to travel a longer distance. This represents the wavelengths becoming higher frequency as the observer moves towards the point, and lower frequency as it moves away from the point. This is Doppler effect.